Welcome, I'm Bill Wake. We're here working on a program to compute medium to long-term financial plans, and we've been working on interest this week. We've made some background progress, but we haven't done any actual computation of interest, so I think we'll get there today. I think my keyboard has died. Well, that works. Why not escape? I don't know what was up there. Okay. Well, one of the things we did yesterday was kind of took a go at seeing about scenario that we need to calculate the amount for something. I guess amount is probably a better place to start. If we have relative amounts, they only make sense in a scenario, I think. Yeah, because if we're doing something, we could have two separate scenarios with the same named Leia, like an income stream or something. I had Social Security at age 62 and Social Security at age 67. I could call them both Social Security. And then depending on which scenario I was in, if you base something off my Social Security, you'd need to know which scenario it is. And yet there's places that don't pass in the scenario. This grew out of the fact that originally all we had was money amounts, and you just said the amount and there was no question about it. So what I'd like to do, and we kind of started doing this end of the day, let's see who calls this without passing in a scenario. And I think we should just make this a required field. Okay, so value and amount. All right, that's us. Okay, so the test, here's a production use, and it does pass the scenario. Now, it doesn't know whether it's got it or not either, but as far as amount, we can do that. Now, we did some of this. We passed in ignored scenario. Oh, we've done that all over. Oh, okay, we did do that in all the situations. Okay, so now we can take this part off and always have a scenario. All right, and I think that should pass tests. Oh, yeah. No longer need to unwrap. Now, yeah, this is Leia that still might not have one. I guess before it was optional, so yeah. Okay, so we'll say there will be one, even though that's probably not something we've quite established. Now, also, I see we're passing in people. This has been my bugbear, I guess you'd say, from when we first did it. We had to. Whoops. Okay. Yeah, I guess we're gonna have to. We're gonna have to do the same thing on signed amount in Leia. Okay, so let's find the people calling it. Okay, unfortunately, there's not a ton. All right, but unfortunately, they don't use the ignored scenario. Let's see. Well, we just create one here. Okay, so let's do that for this. Oh, we've got one here. We just missed it. This one passes the scenario, fortunately. That's our call. And then this one, well, these have a scenario. So yeah, that one has it too. So I think we can take this out now. Oops. Okay, so we'll make scenario required on amount and Leia for value computation. All right, anyway, as I was saying about people, we keep passing this people object around. The scenario, I have more sympathy for that because it's coming from the middle of some computation. But the people one, we're just down on the leaf, and all of a sudden we have a name and we need the person that goes with it. Hey, Eric and Mudshark. Yeah, we're starting off with some more refactoring. We had introduced scenario, well, we have these value computations, and you can make a value depend on another value. So my Social Security is half of yours. Then we need to be able to say what's yours. And so that only makes sense inside a scenario. So we've been passing scenarios in, but we were allowing them to be optional. And mostly it was tests that had a problem with that because they just don't bother creating a scenario up till now. But I think we've cleaned that out. Okay, so our goal was to do some interest computations. Now, let me get our to-do up here. Okay, so pass people to amount, make scenario required for value. Okay, we did that. I lost a day in there somewhere. I guess that was yesterday. Sorry. Okay, so that was refactor. All right. Now, what we're up against, well, we can optimize some of that, but there are basically two approaches I know to calculating the total interest. So I'm assuming we're given an interest rate in annual terms. So maybe you expect to make 7% on average from the stock market or something like that. Now, we can't just divide that by 12, in spite of what some people on the internet think, because it's compound interest. So if we divide it by 12, we're going to get it, we're going to make it too high because it really needs to be a little bit smaller. So when you do the compounding, you get the total value. So I believe what we need is the 12th root, 12 months to a year, of 1 plus the interest rate. Okay, so given that's kind of what you multiply any value by. And it's kind of, I don't know, I knew we needed a timeline kind of thing, but let's say we have our start month and the current month, and this is month 1 and this is month 10. Okay. But so to basically, we could calculate the monthly interest rate, I'll call it monthly rate, to this power of the age in months. Well, this is, well, it's either 9 or 10. I guess the first one is really 0. And then, well, no, is that right? I guess the end of the first month, they got to work out the boundary cases here. Maybe it's, if you start with $5,000 in month 2, you'll have 5,000 plus your interest, I think. So it's kind of an n-1 thing. So in this case, current, well, in 10 minus 1 is 9. So we take our monthly rate to the 9th, is going to be, some number greater than 1, assuming our rates are positive, and then multiply that by the value to get the current rate. The alternative approach is we start with 1 month and then multiply it by our monthly rate, to get the second month, and then we multiply the second by MR to get the third, and so on. And I'm pretty sure that's going to be accumulating errors over time more than the direct calculation. So I think we'll take this approach. I'll call this better and worse. Okay, so that's kind of one complication. The next complication is, some of our streams or assets or whatever don't earn any money until a certain month they kick in. Maybe it kicks in month 5 and we're on 10. Okay. So, we don't want to assume we start at 1 if we explicitly are told it starts in month 5. So, that seems like we're going to have to be a little careful when we get the start month. We'll need to look at the object we're computing with and use that as the start point. Sometimes it'll be 1 if it's unchanged, or whatever we call the unbounded ones. But we don't pass the start of our range down through to anybody, so they don't know what that start number is. So there's more information we need, I guess, is the bottom line of this. And I don't know. Okay, that's the ratio. Okay, that's not, is that calling this? Okay. Yeah. So this, if you ask the Leia, how much are you worth? We should calculate that here. Okay, if the guard date doesn't include it. Okay. Ugh. It's harder to use, it's harder to get the interest to use the n-1 variant. Yeah, it is. I'm more worried about cumulative error, but you're right that it sort of requires you to calculate, from month 1 up to 300 to get the interest rate or to get the asset value at month 300. In this case, we're saying we can calculate it directly. Okay, but I think the deal here is, if I ask you the signed amount at a month, I can't tell you the answer if there's interest involved, because I don't know the start month, and it's always, interest is always, there's an initial month and then you accumulate it. So, let's see. Now, I don't know, we're this unchanged one, the unbounded one on the left. So if you just don't give a start date, we assume it's on the initial month. But the Leias, they have to keep track of like which of those things it are, and they don't know the initial month when we're creating them. So that's something you only know when you come in and ask for the range. So I'm kind of trying to change something on the bottom, but that's hard. Okay, and I'm trying to think of a way to do this without breaking things. But I want to give you a starting month year. Now, I'm going to go to app. I don't remember where we calculate that in the first place. Start date, month year of date. Okay. Well, let's see what we can do with that. Okay, so I'm going to try and take, I don't know, I don't have a good name for this refactoring process. I'm going to take a date that doesn't matter, or that'll always give me the same answer, even though it's not right. No, it's not that it's wrong. It's going to be like if I said I'm going to multiply by a number, but I always made that number 1. It just sort of is neutral. Okay, so let's test our way into this. Leia, I guess. I mean, type has got the bottom line calculation. Let's type. Leia type. Well, all he's doing is signing it. Okay. Right at. Okay. So let's take signed amount. I'm going to say it adds no interest if month is how about if start month is interest for the start month. Okay, that feels like a true thing I can go with. Okay, so we'll just kind of steal. We make a layout. First, I'm going to make this dot unchanged. Layout. Oh, no, that's not going to work. Okay, let me do this one. String, name, amount, dates, Leia type. Name, amount, dates, Cannot convert signed interest. I'm not being very consistent on those make layers, unfortunately. Okay, so if we calculate it at January 2020 with people, whatever, in the ignored scenario, I mean, this income gives us 100, but if the start is also 2020 January, then it should still be 100. Okay. So I'm gonna shove interest calculations in based on this mystical start date. And I'm gonna do start is a month year, and it's nullable. I don't know if I have to say equals nil. Okay, but if I get here, okay, so far this should not hurt anything. Missing argument start. Okay, maybe I have to say equals nil. Okay, now we know where that led us last time. We had to go back and pull all those out. And I think the same will be true with this. Oh, it's amount that does the calculation. Okay. Okay, so no change. I mean, this is kind of a pinning test that it's not supposed to change if it's the current month. Okay, so that is legal. Maybe I need to go down a level to an amount test. Okay, so I'd like to be able to pass that value in. Okay, so let's look at amount value, right? Amount value, okay. Right, value has, okay, at month year. All right, let's do the same thing. Start is month year, question mark equals nil. Okay, again, no change. Okay. And then all right, so here, if start equals nil, and that's the current situation, return amount. Else, okay. Now, ay. Well, let's return amount. Whatever that was. All right. Okay. Boy, this gets ugly. I'm not sure. Is amount value? All right. The place, I guess I got to wonder is who should know the interest rate and how they're going to get it. Okay, so now, for now, okay, so far this is kind of pure refactoring. It's making room for things. Okay, so add start to Leia dot value and amount dot value. Is it value in a Leia, or is it? I guess it's signed amount. Okay. Right. So I guess, I mean, amount is the bottom, right? Because we're just returning some money amount. I'm going to assume relative ones don't add growth. I think that's reasonable because the underlying asset has got its own growth curve. Okay, so the thing is, we don't know the interest rate at this point. Okay. And I guess we're going to have to know it. Monthly interest is a double, is nil. Okay. So nobody's looking at it now. This should still pass. Are you complaining? Oh, yeah, that's reasonable. I'm not too happy either. It will get smaller once we get things pinned down a little. I think we'll be able to get people out of there too. Okay. Right. Okay. So now I'm going to put the interest calculation in for, well, maybe this should come first. All right. Okay. So let's make a test on amount. Okay, so the Leia knows the growth, so it's going to be passing that down. Okay, so test function adds interest based on number of months. Okay, so I need an amount. No, I need a real amount. Okay, yeah, there we go, that kind of thing. Okay. Set equals amount 1000. Okay, and if you call this set dot value, the monthly interest is 25. Oh, monthly interest 25. That should happen. Okay, if we make it 1 month. Okay, missing arguments. Yeah, we need them all. You don't want to fill them in for me. Okay. Start is 2024.jan. At is 2024.jan. What else do we have? People. People and scenario. Ay, ay. Okay. Too much stuff. extraneous labels replace people with people. Really? They just kind of go back and forth at random. I know I normally skip it if it's clear what's what. I guess I felt that here. You're not going to mix up a person in a scenario, but you might mix up the start and the at. Okay, so this will fail because all we do is return the original value. Well, no, this is not even right. Sorry, this should be 1,000. And it'll pass with that. Okay. It gave us 1,000. We expected 1250, but I think actually this one we do expect 1,000, but this one, let's go 1 month out. So we're asking for February, which now should have an interest rate. Okay, and that should give us 1,000. Good. All right, so I think I can calculate my interest rate without blasting everybody else out, because nobody else is going to pass in monthly interest and start yet. Okay, and so what's the amount? Well, we have an answer for that. It is the starting month times the age. The current month minus this minus 1 times that to the 12, whatever. Okay. Let's see. So starting month, well, we're going to take amount times, I don't remember. Gosh, I may have never done exponents in Swift. I assume it's just like everybody else. Oh, no, I want the POW function. Pretty sure it's there, been there since C days. Okay, decimal number raised to given power. All right, so, oh, is there a float version? Let's assume there is. Okay, so I'm going to take the 1 plus the monthly interest to the power of, well, I'm going to take the at distance to, I don't remember which one I'm supposed to put on the front. Start. I think it's probably the other way around. Let's go look. Yeah, it's other minus self. Okay, so start distance to at. Okay, so I got, oh no, really? I want an extra parentheses. Okay. That's the one we saw. Pearl. import Darwin. Power function only wants with Darwin. Okay, where is that function? Well, I don't want integers, I want real ones. Now, maybe I just need to import foundation. Have I done that? I'm getting the other one, I think. Power monthly is power. Okay, amount is int. Oh, money, which is int. Okay, so let's make this double amount. And then money of that. Okay. Start distance. Cannot convert value start to distance at with double. Yeah. Okay, and then start has to be unwrapped, and monthly interest has to be unwrapped. Okay, well, okay, so I'm taking the amount times 1 plus the monthly interest raised to the power of the distance. I think this might be -1, right? The distance from you to yourself should be 0. Okay. I think we're okay. All right, let's check this test. Now, using double arithmetic could give us a little plus or minus stuff, but I'm trying to use an interest rate that generally works with binary, so this should be okay. I mean, 1.10 is already not represented exactly, so if you start multiplying it by 1,000, you're going to start seeing those differences. Okay, so let's generalize this test a little bit. So that's 1 month. 2 months would be March. 3 months would be April. Okay, so let's take I'm going to multiply by 2 more times. I think we'll be okay. Oops. 1953. Does that sound right? Okay. Let's take. Okay. Let's make it 2,000. I just want to get it around. Well, he's still gonna. All right. If we take it to April, it should be 1953. Okay. So okay. So I think we've got our formula in place. Whether it's the right way to get there, and let me leave a note to check check rounding on our interest computation. Okay. So what I think we've done. Okay, so we let amount compute interest given the start month, given the interest rate and the start month. Okay. This needs something. Well, let's extract a helper. So I want to get back. Well, I kind of want to get back to that, I guess. So let's see what we get. Rename field. I wanted to extract method. Okay. So this is principal plus interest. Okay, eventually start won't be nil. That'll get simpler. Okay, amount is money. Dun, 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 dun. Okay, so let's break it out a little bit. Probably could have done tool do that. Okay. Slightly better. Okay, that should be fine. Did I make that private? Yeah. Okay. So I think I think the deal is now we got to make sure that people get monthly interest and start passed to them. All right, so who calls this? Now we only need it if we want it. Wait a minute, where's the people computation? Oh, okay. Okay, if somebody gives me monthly interest of 0, I don't want to do anything. Okay, so now this is the only place that relies on that. And let's do this. Okay. Now, everybody, they should all work. All right, so now I should be able to say double. The start equals nil. Can I say that compared to 0? I'm not sure. Okay. All right, so amount does the right thing at the bottom level. Now we got to get this in. When you ask for the signed amount, well, if the dates don't matter, then nothing does. Where's this monthly interest coming from? Well, that's growth. I just don't know. I'm back to this thing of I've got these global concepts, people, assumptions, not scenarios, but people and assumptions anyway, that I just need to get to at pretty low levels, and they're not I don't know. It seems ridiculous to pass this stuff all over the place, like people. Okay, because the deal is growth is really a string, and it's not like a numeric value. It's a string that refers to a variable that has a particular value at a particular time, but it's on a slider, so it could be anything. Now, it doesn't make any sense to give growth, the Leia, the string doesn't do it any good unless it can look it up. Can I pass in the looked up thing? I don't know. I mean, you edit the variable name. If it were drop down, maybe. Let's, oh gosh. This feels like a big change, and I don't want to make a big change. All right, let's trace our assumptions. So each assumption right now is just a struct. And its current value is not an object. I mean, well, I guess the alternative I'm looking at is, what if we passed assumptions around these assumption objects, and then the current value is variable. Yeah, that's what I'm wondering. But like right now, this is just a struct, and so it doesn't do anything. If you set it, it's just a constant value. Now, does that mean this should be a kind of a wrapped value? Golly, where's assumptions? All right, this thing is our top level thing that's just kind of an array of these guys. Well, and I think that we probably need the same change in people if we go that way. Right now, we just get their person's name and don't have access to their birth date or whatever it is we're after. Okay, well, this is also, like, we don't have access to the global variable either. I mean, this is good in a way, but it makes it harder to work with, right? We have access to the global state. We can look it up and pass it around, and we stick it in the environment so any view can get to it. Well, that's the thing. I don't know if we... I guess this is the reason we're doing the string, right? If somebody were to delete, we'd made the assumption ROI, and we keep it in the assumptions list. Now we keep the name of it in the Leia, and when it's time to get the value, you ask the assumptions what it is. We haven't done that yet, but that's the goal. If we kept the actual assumption in the Leia and somehow made the value variable, but somebody deleted it from the assumptions, like that Leia's floating around that isn't in our list of assumptions anymore. So even there, it's kind of bad. If the assumption changes, the struct will be replaced. Unfortunately, no. Or well, maybe if I change it in the assumptions list, yeah, let's go there. Assumptions and assumption. Okay, so yeah, because assumption is a struct, if somebody edits it, we get a whole brand new struct with its values. And if they delete it, well, now the lookup fails. Now, you could. The problem is everything is trying to couple these things together more and more, and I want them decoupled, and yet I'm struggling. If we could say, if you delete an assumption, we go through all the Leias and kill off anything that references it. Okay, but now that means assumptions have to know all the Leias, and Leias have to know all the assumptions, and that's how you get in these nasty situations, Now, if assumptions were an object and you put it in the Leia, a reference to it, and you put a reference in the assumptions, they both can refer to the same object. And if the min changes or the current or the max or whatever, that would all be updated. But if it got deleted, then we have some trouble. But maybe we don't. I mean, whoever the delete action, well, it's on the assumptions. So if you go in the list of assumptions, hit delete. I don't know who we call, but we probably just call assumptions. Here's remove. Okay, so here's the assumptions view. Right. So, we could say this place knows, well, no. This thing does not know the Leias or the plans or the scenarios. He could ask for it. Fume app does know it. Oh, this is so painful. All right, and meanwhile, I'm just down in Leia trying to get the interest rate. Okay, but to do that, I have to ask, well, right now I have to ask the assumptions. Do you have the assumption named growth? And if you do, look it up and give me its current value, and I will update my amount. Now, what's going to change amount? How does sliding a slider around affect things? I'm not sure I know. We would have to trigger a recalculation somewhere. Now, or we pass in assumptions like everything else. Like, these things are assumptions, people, and scenarios, plans, whatever the top level thing are. It's like we're starting to pass everything around, and every function ends up knowing about people, and most of them couldn't care less. Well, okay. Another possible way. We could put, no, people is separate. We could have two Leias depending on the same person. Then we can't just have that person. What I was thinking was, if the list of people were derived by walking through the Leias and grabbing all the people inside, and then when you wanted to view them or edit them, they would be there. Ugh, I just don't know what to do. Passing everything around all the time is just kind of ridiculous. And yet, going out and grabbing a global in the middle of things is not very safe either. Okay. Yeah, so I'm wondering if we could make the list people be generated by walking through all the Leias and pulling out any people fields that get referenced, rather than independently maintained. But that still doesn't help you if you delete something. Like, you got to go through the Leias and delete them. They don't make sense. Or else you just wait and blow up and realize, like, hey, I can't calculate your date because you don't exist anymore. Which is kind of what we do now. Weekly. Yeah, you have to use all people. Right. Yeah, if you had a person that you hadn't used yet, like, how would that even be making sense? And I think having the people separate makes sense. I mean, that's like the thing when you start, who was involved. Well, me and my spouse, maybe an ex-spouse, maybe a kid or something. But, your family's probably not changing every moment of the day, So, well, the very expedient way is I make this public. I mean global. And if you haven't used a person, you don't need them. Well, you don't need them yet, right? I mean, I think of like the financial planner situation. You come in and they say, okay, first question is, who are we talking about? Let's see, there's you, your spouse, and whoever else. Okay, enter those people in. They exist before you decide that something's going to depend on their birthday. Because the only reason we need the birthday, well, right now, the only reason we use the people is to get their birthday on the cases where you have something that depends on their birthday. So retiring at age 62 depends on the date of my birthday, and I need it for that. So, okay. So my way around this is I'm going to create, well, a way around is to create the singleton, but a singleton is really just a fancy name for a global. So it's anything that's bad about globals comes in with singletons as well. But what I need to do, right, is at some point I want to ask, and we haven't even done this yet. We can check if a name is in there, but we haven't pulled out the value. Okay. Okay, and I don't even like the way we do that. But at some point, I want to get my assumption. Oh, here I can get it. Okay, so I can do a find. Ugh. All right, so right, let's do that. Static assumptions. I don't know how we like to call these. I'll say singleton. Can I say var? Oh, that's not how you do this. There's a default initializer, something or other. Deferred initializer Swift. Yeah, that's the easiest way. Yeah, this is the one I'm thinking of. You assign, and this makes it called. Okay, yeah, shared's a better name, isn't it? And we'll make it public. Okay. So that's there. Let's get FumeApp. Make sure everything hangs together. Yeah, I'll go back to this. So this variable like this, I think just gets called implicitly. I guess we're creating a closure and implicitly calling it to initialize it. Okay. All right. So we're going to add okay. Now, is that all right? So, all right. So that's just a variable at this point. Everybody's going to get the same one. All right. So let's get into. I guess it's Leia is going to be the moment where. I mean, to get the monthly interest rate, we need to look up the growth. If it doesn't exist, default it to 0. If it does exist, use it. And what's going to update this? I don't know. We're going to have to do something probably. Okay, so if you're asking for the assigned amount, all right, so I guess we're going to create a layer with we'll create an assumption with an interest rate. The layer will use that assumption and it will have to look up assumptions to find it. And then pass it in with that. We got to get a date too. Just too much, but we'll get rid of people soon. Okay. Where is the initial date range? I should probably just keep FumeApp open because he knows everything. Start date. And that is the thing we want to know. I'm going to do the same thing for month year. Month year is going to know the start date. And I don't know if that's the best way to go, but and this date is tricky to get to. I think right now it's not used very much. More than that. Oh, let's just look for. Okay, so it's used in basically the chart is the core thing. So we are going to view the chart starting at such and such date for a range of some fixed number of months. I think we hard coded it. Yep, 360 months. And the plan view needs to know them starting at start date. And it's really the net worth calculations that come back to that. Okay, so maybe we can range, we'll do net worth. Okay, we got the range. We needed to compute this stuff, but so, I mean, he could pass it in. Well, this could be passed down. It's not that far. Signed amount at month. Did we add the start already for that? Yes. Okay. So start is range lower bound. Okay, so those do know that. Okay, so if the calculation already knows the lower bound, that's a good thing. All right, now we're not using it anywhere. Signed amount, start. Right, but this could get the start. Okay. All right, so there should be start is well, where is that coming? Sorry. Yeah, start is start. Okay, so calculation at this particular start month. Okay. Again, I don't think there's any harm in passing that in at this point. It's getting the real thing. Okay, so we're not using it, but that gets us going. Okay, so we're passing the start date in. Date through to Leia. Okay. All right. So amount can work with it if it's given the right stuff. Signed amount on Leia can work with it if it's given the right stuff. I think the production uses now give it the right stuff. Amount. Oh, this one does not, interestingly. But I think he has it. Yeah, he does. Okay, so he could pass in monthly interest and start. Signed amount. Okay, let's check this back. Amount, monthly interest. He has monthly interest and start. He passes them along. Okay, this one gets it. This one does not. Start is ranged at lower bound. Right, net worth does not know the monthly interest rate. That's not up at his level. Okay. So this should all still, it's people passing around nils most of the time, and we haven't looked at these usages. Could they do the rest? Okay. So let that run that test. Okay, line length. Yeah, again, these are getting long, but I hope to shorten them. It's not the worst thing in the world to follow this habit for anything over an argument or two. Just put one per line. Okay, so test should still pass. Yeah, I missed one. Oh, I didn't call my helper. Oh, I did. Okay. Okay, so I guess we're pass through the monthly amount and start date. All right. Okay, so back to Leia. So the monthly interest we got the start date passed through, so that's cool. We can look and see who's using it. And production uses should have it. Monthly interest and start. But Leia, wait, signed amount. Oh, that should not be passed in here. Whoops. Okay, we'll just default that still, because this is something known in signed amount. Okay. So let's make sure that doesn't break anything. Yeah, this is kind of a painful change. All right, I think same argument. This is the relative. He's going to take whatever the Leia has, so that's fine. Okay. Well, let's push that. Yeah, it's funny. I mean, the interest calculation itself, we're kind of done with. It's there, but getting the right context everywhere to use it is the tricky bit, for sure. Okay, so I think what we have here, I think we're ready to write another test instead of all this weird refactoring. Okay, and the test is if there's, well, let's do the easy one first. If there's no growth field, then the interest rate is 0. Okay, so oh, and I got one more question. Sorry, before we get too far off. Does everybody calling this pass in start? They don't. Production uses do. Okay. I guess we'll let that go for now. All right, but let's get to Leia and do a test. All right, if there's no growth set, use 0. Okay, so we'll do this. All right. Income. Well, none builds it in, but maybe it defaults there. I guess I should figure that out. You're right. I think we do default that. If you do a find, no, we give nil. We call verified, which does force none. Growth. Okay, I think we are forcing it then. Assumption verified none. Okay, so let's do a different test then. Let's do the real test. Let's make some assumptions. Well, we're gonna do an add. Dot add assumption. The type percent, the name is inflation. Minimum 0, maximum 100, current 25. Now let's do 50 just to be a little different. Okay, and we have 1,000. Okay, so we're adding in this assumption. I think again I'll call it out like that. 50% inflation. All right, and then in the Leia, I don't think make Leia takes the growth. I don't know if we can set. It defaults it. Let's see if we can edit this. How about we do var here? Okay. And then set dot growth equals inflation. Okay. And if we take set dot signed amount and we'll start in 2020 January, and we're going to go to 2020 February. We'll use people. Even when I'm doing this, I can't do it. Scenario can be ignored. Scenario. Type money cannot be used as a Boolean. Right. Equals 1/500. All right, that's a good test. All right. So this is a Leia with growth set applies it. How about just Leia applies growth? Okay, because they don't know. All right, create an assumption, inflation, 50%. Create a Leia, 1,000 income, kind of generic. Change the growth to inflation. William W., 42, hello, welcome. We're working on a financial app and we're trying to let it do things like add increased values for inflation or return on investment or other characteristics. And it's been, I haven't been totally lost, but it's definitely been a bit on the messy side. All right, so we have this thing with 1,000. It says apply inflation for the growth. And if we run it for 1 month, it should grow once, 50%, and get 1,500. All right, and I predict this test will fail. And the reason it fails is we don't have anything that looks up the growth rates at this point. What happened there? Oh, 85 tests. Okay, I saw 85. It's like, what? Okay, so it comes back 1,000, which is the standard rate, does not apply the growth rate. Okay, so now we're going to look that up. I hate it in a way, but that's the breaks. Okay, so assumptions.share.find of growth. Well, Growth is optional. Okay. Let's do the assumptions. Find growth. This. No, it's not going to like that. Okay. A good way to pull this out. Okay, we'll take the assumptions shared, find growth. It's not nil, so that's safe. Otherwise, it comes back 0 if it doesn't find it. Oh, this dot current. Okay, and then really. I don't know if that's gonna. Should find return null assumption if it can't be found. That's I'm not sure. Part of it is I'm looking forward a bit, but we want to have assumptions that are either dates or ages or other things. If find allows for nil, you don't need it to check here. Yeah, does find. I don't think it does. No, it assumes it's there. Okay, does this work? I guess that's the question. No. Oh. Okay, that's a little large. It's divided by 100. Now, okay, that's good. Right. Let's make Leia look up assumption, look up growth assumption and apply it. Okay, so we'll stage all and commit. All right. I think we're kind of there, but yeah, it's time for a break. We'll come back and this whole thing, if I had a method on assumptions that said find percent for a given name, it could give me back exactly the right thing, and that would make this better. So we will take our break, come back, apply that, and see where we are. Thanks. See you in a few, 3 or 4 minutes. All right, welcome back. So let's pull together this computation into assumptions. And well, let's test drive it in. Okay, so we're going to take function. Let's do the easy one first. If it, the assumptions returns 0% if name is null. Okay. This should be returning a double. Okay, this does not exist. Okay, clearly wrong. Oh. A little too wrong. Okay, there we go. Okay, so, well, we got 1 or 2, right? Got a 2. All right, so if name is nil, then we want to return 0. Oh, I didn't test the thing I said I was going to. And that 2 was unexpected, actually. I should have caught that. But now it should be good. Okay. Now let's test. I'll turn these around. Now this will get a 2, should get a 0. Okay. I don't know how to do a compound one with a let. Can I do this? Oh, okay. Should pass. Good. And then finally, we're going to add one. Name is RY. Okay, so returns. Keep this similar. Okay, create the assumptions, add the assumption for ROI, and we expect to get its value back. Should get a 2. All right. Growth. So I think we've dealt with this case. We know growth is not nil. The name is not nil. And we have assumption dot current divided by 100. Well, we can, nope. Let's make that clear. Okay. Did I get it wrong in my test? Yeah, I did. That order throws me. I'm the one that changed it. Okay, so now we don't need this. We're just going to take assumptions.share.find% of growth. Okay. Okay. Something's wrong. Oh, we're not running? Let's run. Now, I don't know what's in here. I put in an example. I'm writing a blog. I'll publish it whatever the first Thursday in September is, on these and or trees that we're using to represent the scenarios. So we have an annuity and two spouses with Social Security. So I changed the example we had running. So, but right now, let me delete these. We'll keep this one. We have an assumption. Okay, let's do ROI. And let's change this to ROI. Now, that should change our graph dramatically. Ugh. Oh, growth none. Wait a minute. What happened there? Oh, I did what I always do. I forget to hit update because it's not visible. Hey, that's like it. Okay. So something's weird. Something's cool and something's weird. So the cool thing is, if you start doing interest, you should start seeing exponential growth, right? I mean, that's kind of normal. The growth in here, e to the 15th, right? E to the 7th is a million, so we're talking billions and billions. It seems suspiciously high. Oh, it is. Okay. The problem is this is returning annual percent. The assumptions return annual percent. So yeah, the growth is so high it makes the line seem flat. I think it's growing, but this is, what's 14? So millions, billions, trillions, maybe pushing a quadrillion. A lot of money. Okay. Maybe not more than there is, but kind of a lot. So yeah, this is, I think I want to make this be monthly percent. Yeah. Yeah, and the best thing is, you're probably at a billion here somewhere. I mean, a billion is about a tiny, tiny, tiny dot on the line. So you made your money really early. Okay, so where is this thing? Assumptions. I'm going to change this name. I want monthly percent. And my test does not test for that. Okay, so if well, the 12th root of something is pretty big, right? I mean, 2 to the 12th is 4,096 if I did my math right. So I'm going to say Well, let's make this big. If I get the current value of 4,096, the monthly rate should be 2. Is that going to work as a decimal? 12th root of 4,096 is 2, so 2%. That's not very binary friendly. So we're gonna have to we'll see how close we get. Okay. But this test fails. Okay. I assume it will fail. It gave us a different answer a moment ago. Yeah, we got 40.96 divided by 100. I guess it's percents. Yeah, okay. Right, but what I really want is the 12th root, which is power. Yeah, we got foundation of this to, I guess we got to convert it inside. Okay, assumption of current is the 4,096. We want the 12th root. Is that the, no, is that the minus 12? Am I getting them backwards? Minus 1 is 1 over x to the 1/12th. Okay, if I take the power of the current thing, assumption.current is somewhere I have to divide by 100. Am I writing this correctly? We'll see if it's, 0.019872. One test failed. Leia.swift. Yeah, because I didn't do that right. But why did this not fail? Leia. Yeah, that's better. Let's take this. Where's my 12th root calculator? Okay, so if you take this 12th root of 0.5, it's 0.94. Twelfth root of 1.5. $1034. What am I doing? Okay, so the signed amount. Okay, so the value should be 0.5. It should be 1.5, the 12th root of that, times, oh, how many months? 1 month. What am I doing here? Well, I'm not getting 1,034 then. Well, let's break here. I mean, it seems like my other one's passing, or maybe it just blew up too soon. I don't know. Okay, and then we'll stop and find percent, and we'll continue. No. Oh, is that what it is? Or is that my... Oh, 1385. Am I writing this wrong? Isn't it 1 over the value? Am I... No? Well, we can see why it's getting the answer it's getting if it's 0.01385. I'm leaving out a 1 somewhere though, aren't I? Ugh. Okay, current. We have to divide current before we do anything, right? Sorry. Stop this. Okay, so my assumption.current is 50. I'm going to convert it to a double and divide it by 100. And now I get a percent. But it's got to be 1 plus that to the 1/12th. Right? Okay. Double, okay, the assumption is 50 over 100 is 0.5 plus 1 is 1.5, and then that to the 12th root. Okay. Try again. Okay, now I think we'll get a different answer. 2034. I got my 1 in the wrong place. Jeez. Right. No. Okay, if I take 1.5 to the 1/12th, is that what we calculated over here? 1.5 to the 12th root. 1.034. Should the 1 go in front of the power? I think you're right. No. Okay, let me go back to my to-do. I didn't write my formula very well there. I'm not sure it's going to help anything. We're going to take the value times this age, but the value was 12th root of 1 plus the percent. Annual percent. The 1 is so you get back to the full value. So if we just did the point, let's say we did 0.5 and we took the 12th root of that and it's some very small number, we multiply it by 1,000, we would get the interest, but we wouldn't get the principal. So the 1 gives you back the principal plus some percentage of the principal, which is the interest. Oh, golly. Now, excuse me, if our annual rate is 50%, then in a year we should get 1.5. And so if we take the 12th root of that, we should get the number for 1 year. So this may be, yeah, it's the 100%. Is it the 12th? Am I screwing that up because of the boundary? I mean, I'm saying you're not getting any interest the first month, which maybe is not quite correct. Well, I guess the first month, 1 year later, is the 13th month. So maybe that's not so bad. It should only affect this, and 1,034 looks like a reasonable answer. 1.034 to the whatever is, so after a year, we should get 1.5 times our original value. Have I got that formula? I'm taking the 12th root of the percent. Okay, I'm going to go back to breaking here. All right, let's double check my test. Inflation is 50%. Start on $1,000. Well, we think it really should be 1,034 now. Okay. So if I take, all right, I'll break here. I will run tests. Actually, I'll break here too, if I can. Okay, so that's this one. Let's step. Okay. So we'll continue. Okay, so the name is inflation. Step over. All right. So let's print. Well, let's print the pieces first. $1.5. Good. Okay. Now, this. Now, if it doesn't come out to exactly, if it was 103.5, 103.4. Okay. That looks right. Start is sum. What does that mean? What? January 2020. Month is February 2020. Okay. Let's go here. And then money is 2034. Well, 1.034 times 1,000. Yeah, 1034 is the interest for each month. And if you multiply those out, oh, he shouldn't add the interest, should he? Let's see what we're doing. Leia. Oh, right. You're right. Oh. One. So I shouldn't add that one in the, that's not the monthly interest, right? The monthly interest is that. Okay, thank you. Let's make sure that's good. I got another breakpoint somewhere. Two failures, okay. That's 1.36, blah, 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 okay. This is 1943. Well, it looked better when it was 2034 because that sounded exactly right. Goodness. Okay. Let's go back here. We take 0.5, 50 over 100 is 0.5. Take the 12th root of that. Oh, the 12th root should be on the whole thing. I'm I think the 1 plus belongs here, but not on the other one is the deal. And maybe monthly rate is more accurate. And then where was that calculation? Principal plus interest. Okay. Distance. I think that is principal plus interest now. Okay. To be so far off, it's just weird, but we're not used to working with 12th roots of things and stuff like that. Now, why did this one pass? Well, he didn't. Okay, good. No, 2 failures. 1.36, and is it Leia? Oh, where's the other failure? Okay. And amount. Okay, this is not monthly interest. Okay, that's 3. Okay, this one. I don't know if saying it's monthly rate is the factor times the thing. Should be 1.25 under this circumstance, but I'm going to rename that. The other one's not very good though. But that says this one passed. Is approximately monthly interest at 34%. Okay, where's an amount? $1.25. One failure, and I assume that's in here. Yes. Okay. And, okay. Well, this is too clever. Well, let's take 100. Okay, so 100%. Twelfth root of 2, good number for a piano tuner to know, is 59. Now, the weird thing about this site is I don't think I can copy numbers, like bizarre. Oh no, it's okay. All right. And I think this is going to be off in the last decimal place or something like that. But a lot closer. Okay, so if it's 100% per year, 59% a month should do it ish. Okay, 594630943. Okay, yeah. So, I forget what you do for fuzz. I think you have to use some weird helper function. Swift testing approximately equal. I know they said something about it in the documentation. I think you're supposed to use some other helper function that that's not the right stuff. Expressive API, but we won't tell you where it is. Okay. I put this here because I keep using it. I don't think I said. Yeah, the Swift testing library does some. That's too bad I didn't put it in here. Oh, but I've got the link. Expected values. Here it is. It doesn't provide equivalent. Use approximately equal from Swift numerics. Yeah, which seems like a lot of work to get that. Okay. Let's do it this way. And then we can do this. 9. Oh, 9, 4. Okay. Clunky, but I'll take it for now. Okay, good. And have we got any errors? No. Okay. Um, okay. Okay, well, I think that rounding is fine. 5 or 6 decimal places. That seems great. Okay, so do we need to pass to amount of value? All right. So yeah, I think. Well, let's run. Our annuity should not be in the 10e to the 15th range. It should have a curve. That's better. Okay, $2 million, I buy it. Yeah. So, cool. So if you've got this, now I wonder, I can't see it. I lowered my inflation. It does not lower. Okay, we're going to have to work on that. All right, but this is good. I mean, this is the kind of thing you expect to see. I don't remember what our growth rate was. I think it was 5 or 7, 5% inflation. Oh, it was ROI anyway. Let's try editing the right one. Just for grins. Oh yeah. Okay, so a 6% is a little under 2 million. It was over it with 7. Okay. And now I would really love to have it. Well, I'd like to have this screen half the size, this table, and have this go when I manipulate it, like as I drag. But I may be greedy. Okay, but 4%, another percent cuts you down. Yeah, it looks like a good growth curve. I mean, it's plausible. Maybe we'll take we'll find a mortgage calculator tomorrow and put in the numbers kind of going the other way. Can we do that? Yeah, like if I buy $100,000 house at 7% interest and I pay 0% a month, like how expensive is my house in 30 years or something like that? Yeah. Okay. Cool. Well, let's update this, make growth work. But what we did, okay, so calculate per month by taking starting value times monthly rate to the number of months. Okay. And calculate monthly rate as 12th root of 1 plus annual percent. I guess that goes up. Okay. And see smooth growth curve on a simple annuity. Right, so that's cool. All right, I think the rounding, I think that's not worth messing with. Okay, this is more of a refactoring change. Improve display assumptions. Okay. Yeah, this is good. I mean, the rates respond to the slider, I want to say real time, is probably what I'm really after. And I want to just make the assumption display half as tall so we can see the impact. Okay. Well, this is good. We will pick up there tomorrow. Thanks for joining. Thanks, Mudshark, for your eye on the tricky math, and the others if you're still on. Yeah, I mean, I think we've got the heart of it together. And we'll do some work to make sure the exact values look good and everything. But I think we're making progress. All right. Thanks again. Take care. Have a good evening. Bye bye. Oh, back tomorrow, 2 to 4:30 Eastern, 6 to 8:30 p.m. UTC.